from the logcat router. Parameter time S and time E represent the time when the first and the last ping response packet arrive at the logcat router. And parameter N receive represent number of ping packet which respond and arrive at the logcat router. The relay capability estimation can calculate by using bottom equation, which is the total length of data received at the router divided by time when the first and the last ping response packet arrive at the router. And in the logcat router, it's classified peer into high or low relay capability peer by reference at double value of video play data rate. A peer is judged to high relay capability peer if the result of the relay capability estimation over than double value of video play data rate. And a peer is judged to low relay capability peer if the value of relay capability estimation equal or lower than double value of video play data rate. This page shows determination of delay insertion. The delay insertion will equal predefined maximum value if the router detects low relay capability source peer and high relay capability destination peer. The additional delay will grow up proportional to AS hop distance if both source and destination are high relay capability peer. The additional delay will equal 0 if the router detects the destination peer is the low relay capability peer or not yet detect any video data delivered between this pair of peer. This page shows time sequence of the logcat scheme. The Roman item represent the ordinary packet and function generated by P2P TV system, and the Arabic number represent the extra function and packet which generate from the logcat router. First, new viewer peer request peer list to the P2P TV server and server reply peer list back to the new viewer, and then new viewer extract the peer IP address from the peer list and send hello packet to the current viewer, and current viewer reply hello packet back to the new viewer. During the reply hello packet sent, if the logcat router detect the hello packet, it can extract source and destination IP address, and then it can estimate AS hop distance. After that, it estimate relay capability. Next, video data request sent from new viewer peer to the current viewer peer, and current viewer peer sent video data to the new viewer peer. When the logcat router detect the video data, it can estimate video data direction, and then it calculate additional delay. The additional delay will not insert into P2P TV packet immediately. It waits during buffer period, which require high bandwidth resource, and the logcat router start insert delay after buffer period, which is a playing period. For the video data direction estimation, the logcat router detect the P2P TV packet which the length over than 1000 bytes and extract its source and destination IP address, so it can estimate video data direction. This page shows experimental setup of the logcat scheme. Is quite similar to the ATO scheme, but the extra note is here. which is the low relay capability peer, I use Android smartphone, which access internet via 3G network. And Android smartphone use 3G network, which served by OCN, which same AS network as the delay insertion router. And I reduce number of arbitrary provided peer into one node, which placed in SoftBank broadband network. This page shows evaluation of this relay capability estimation. I set ping data rate at 5 megabit per second, and ping parameter L is vary from 700 to 1500 bytes. So there are 5 pair of ping parameter L and T int, which present in the green table. For the between delay insertion router and Windows PC, I set a variable bandwidth at 5 megabit per second, 10, 20, 50, and 100 megabit per second. The limited of the available bandwidth is done by a dummy net function. And for the estimation result at the Windows HPC, the relay capability estimated result is increased with the large of parameter L and T int. And when consider the relay capability estimation at the Android smartphone, the result is around 0.3 megabit per second because of the limited to the uplink bandwidth of a 3G wireless connection. Next is effect of relay capability estimation on terminal CPU utilization. In both Windows PC and Android smartphone, CPU utilization slightly increased with the large of parameter L and T int. So throughout the dissertation, I set parameter L and T int at 1500 bytes and 2.4 milliseconds for maintain the CPU utilization of terminal and maintain the effectiveness of relay capability estimation. Next is evaluation result for the case where high relay capability peer is a new viewer peer. For easier explanation, the new viewer peer is the Windows PC, which can download streaming data from the Android smartphone and other neighbor peer in the internet. I consider metric at Android smartphone are average data rate and CPU utilization, and at the Windows HPC are downloaded traffic and throughput. For at the Android smartphone, let's focus at the data rate. ATO scheme lead Windows HPC download streaming data from Android smartphone. So when consider the average upload data rate at Android smartphone, ATO scheme increase average upload data rate at Android smartphone highest among all scheme. And for the logcat scheme, the router lead Windows HPC avoid download data from the Android smartphone, which is the low relay capability peer. So when consider the average upload data rate of the logcat scheme at Android smartphone is lower than ATO scheme, and logcat scheme can save 17% of a total available uplink bandwidth when compared to the ATO scheme. And for the download direction, the data rates are equivalent in every scheme. Next, let's focus at the CPU utilization at Android smartphone. ATO scheme In ATO scheme, the CPU utilization at Android smartphone is highest among every scheme, and Logcat can reduce CPU utilization when compared to the ATO scheme. The Logcat can save about 5% of CPU utilization. However, the saving CPU utilization at the low relay capability terminals is the minor benefit of the Logcat scheme when compared to the major one in terms of the available uplink bandwidth saving. Next is traffic result for the high relay capability peer. I evaluate the download data at the Windows HPC and the duration time of experiment 60 minutes. For the ATO scheme, which lead Windows HPC download streaming data from the peer in the same AS network, there is a 36 of total data received from the low relay capability peer which placed in the same AS network. Next is Logcat scheme, which avoid video data from the low relay capability peer. So there are no video data from the peer in the same AS network. But 63% of total data received is downloaded from the one AS hop distance away, which can indicate that Logcat can efficiently avoid video data from the low relay capability peer, while consider traffic localization simultaneously. For the no delay control scheme, because of without any traffic localization function, most of video data download from 2 and 3 AS hop distance network peer. This page shows throughput over elapsed time for the Logcat scheme, which is avoid video data download from the low relay capability peer. There are no throughput from the internal AS network peer, which is the low relay capability peer, as represented by the red area. And a large part of the throughput is download from one AS hop distance network peer, which is represented by the green area. Next, let's consider ATO scheme. ATO scheme appear a part of download throughput from the low relay capability peer in the same AS network, which are represented by the red area. And for the no delay control scheme, most of throughput download from the high AS hop distance network, which represented by the blue and the white area. Next is video quality evaluation at the high performance terminal. I evaluate video quality at the Windows PC. This figure also shows the experimental setup. The setup is quite similar to the ATO scheme in the previous section, but there is a change in the third viewer, which is the Logcat scheme, and set the unit at 150 milliseconds. Using degradation mean opinion score, the result of video quality over elapsed time shown in the bottom graph. The Logcat scheme can maintain video quality close to the ATO scheme and no delay control scheme because it avoids video data download from the low relay capability peer. Next is CPU utilization at the delay insertion router. The result is shown in this graph. X-axis is amount of users and Y-axis is CPU utilization. Logcat scheme can maintain CPU utilization close to the ATO scheme, and for the scalability, if set threshold of CPU utilization at 80%, the Logcat scheme can calculate the capacity from the linear formula in this graph. The logcat scheme can support 4,166 users. To conclude, logcat scheme. The logcat scheme is a development of delay insertion-based P2P TV traffic localization by consider peer delay capability and precise network information. For the evaluation result, logcat scheme when compared to the normal P2P TV system, it can efficiently localize traffic in the low AS hop distance network. And when compared to the existing ATO scheme, logcat scheme can avoid relay traffic from low relay capability peer. And logcat scheme can optimize uplink available bandwidth consumption and CPU utilization consumption at the low relay capability peer's device. In the previous section, I present the methodology, experiment, and result of the logcat scheme. Next is the last section, which is the conclusion and the future work. For the conclusion, this dissertation proposed a delay insertion-based approach for P2P TV traffic localization, which consider insert additional delay into P2P TV packet, which come from or go to external AS network. There are two traffic localization schemes. First is ATO scheme, which calculate additional delay proportional to AS hop distance. And the second scheme is the logcat scheme, which calculate additional delay, consider peer's relay capability, video data direction, and proportional to AS hop distance. For the benefits of the proposal, when compared to the normal P2P TV system, both ATO and logcat scheme can effectively realize traffic locality and reduce inter-AS traffic. And when compared to the existing delay insertion-based scheme, both ATO scheme and logcat scheme can localize P2P TV traffic in the AS level, which is a precise network topology. Next, logcat scheme can avoid problem of scarce uplink available bandwidth consumption and CPU utilization at the low performance peer terminal. And for the future work, the P2P TV traffic filtering process was skipped for reduce the scale of this research. However, I considering many various methods. For example, deep packet inspection, port number detection, and shaping device installation. This brings me to the end of my presentation. After this, I appreciate every question or comments. Thank you very much for your attention. ขอบคุณครับ